terminology. So I've used box and square and circle and triangle as dummies for any sentence. I'm going to use the symbol 1 in a circle and 2 in a circle for variables. Okay, so I'm going to give you some examples of binding first and then define it. So in this case, for all x, if fx then hx, we have a bunch of binding. The x in the antecedent is bound by the universal quantifier x, and the x in the consequent is bound by the universal x. So binding is a relationship between a quantifier and variables. So for all x, if for all x fx, then some x hx. So the x in the antecedent in the fx is bound by the universal x. The x in the consequent is not bound by the universal x. It's not in the scope of the universal x. The x in the consequent is rather bound by the sum x. And now we have for all x, if fx, then some x hx. Okay, so the x in the antecedent is again bound by the universal x. The x in the consequent is not bound by the universal x. Why? Because it's also within the scope of the sum x, and the sum x is closer in the tree to the x in hx than the universal is to the x in hx. So how do we define this notion? So we have a quantifier phrase with a universal and then a variable, be it universal quantifier phrase or existential quantifier phrase, and it binds a variable that occurs somewhere in the sentence or the formula if and only if two conditions are met. The first are well, if and only if following the quantifier phrase, it's the first quantifier phrase in the tree above the variable occurrence, and they match. So let's see an example, or see what's going on. So here we have two quantifiers, the for all x and the sum x. So the for all x is above the x in fx, and it's also above the x in hx. The sum x is above the x in hx, but it's not above the x in fx, and the sum x is the first quantifier above the x that matches the x. The universal x is the first quantifier above the x in fx that matches the x. So the x in fx is bound by for all x because they variable match, and the universal x is the first quantifier above that x to match it. There's the scope of the universal. The x in hx is not bound by the for all x. Why? Well, it matches the variables match, but the sum x is the first quantifier phrase that matches the x in hx to come above the x in hx. So that's why the for all x binds the x in fx, but not the x in hx. So that's binding. So just some examples. Free and bound. So A is a name, so it doesn't really make sense to talk about it as free or bound. We only really talk about variables as free or bound. But we can call it free if we want to. This x is free because there are no quantifiers that occur above it in the tree of this formula. So what do you think about the x here in fx, free or bound? It's bound because there is a quantifier that matches it and it occurs above it in the tree. The for all x, if fx, then gx. Again, both of those x's are bound because they match the x in for all x, and the for all x occurs above both the x in fx and the x in gx. For all x, if fx, then gx. So in this case, the universal is part of the antecedent. So the universal has scope over the x in fx, and so it binds the x in fx, but the universal does not have scope over the x in gx, and so because it's in the consequent, not in the antecedent, and so the x in gx is free. Here we have a fairly complex sentence. We have a conditional. The antecedent is for all x, fx, or gx. The consequent is hx or some y, ey. The universal x in the antecedent occurs above the x's in fx and gx, and so binds both of them. The universal does not occur above the x in hx, and so does not bind the x in hx. The x in hx is free. The y in iy occurs beneath the sum y, and so the I in iy is bound. So those are examples of binding. And as we'll see, the rules will be specified partially in terms of binding. It's not absolutely critical that you super understand this notion now. You'll get to understand it as you use the rules, but you need some introduction to it to have some idea of what's going to be going on when the rules are introduced. So that's this video. We'll be on to the rules in the next video.